Welcome to chemistry classes. In this video we are going to discuss about aldehyde and ketone, physical and chemical properties of aldehyde and ketone. Okay, so here first we can discuss here physical properties of aldehyde, and ketone. Okay, so here methanol, these are the lower aldehyde, methanol and ethanol. Methanol, it is gaseous state. Methanol, it is vapor state or gaseous state, and ethanol, it is volatile liquid. Okay, ethanol, aldehyde, not ethanol. Ethanol, it is volatile liquid. Okay, other aldehyde and ketones are solid state or liquid state. So here methanol, it is gaseous state. Ethanol, it is liquid state. Okay, ethanol, volatile liquid. Other aldehyde and ketones are solid state or liquid state. Okay, and here compared to hydrocarbon, aldehyde and ketones shows higher boiling point. Okay, here compared to hydrocarbon, carbonyl compound, aldehyde and ketone, which consist of carbonyl functional group, and they are polar. Okay, and they make strong intermolecular force of attraction compared to hydrocarbon. That's why aldehyde and ketone shows higher boiling point compared to hydrocarbon. Clear? And here next point, lower aldehyde and ketones are miscible with the water. Okay, aldehyde and ketone which contain less number of carbon atom, they are miscible with the water. They dissolve in the water because this carbonyl group, aldehyde or ketone, which contain carbonyl group, it is polar and they make intermolecular hydrogen bond with the water. Okay, aldehyde or ketone which contain carbonyl group, this carbonyl group make intermolecular hydrogen bond with water. That's why lower aldehyde and ketones are miscible in water, dissolved in the water. Okay, but the solubility of this aldehyde and ketone decreases with increasing number of carbon atom. Lower aldehyde and ketones are miscible in water. Lower aldehyde and ketone mean aldehyde or ketone which contain less number of carbon atom. But the solubility of this aldehyde or ketone decreases with the increasing number of carbon atom. Clear? Next point we have to discuss here, aldehyde and ketones. Aldehyde and ketones soluble in organic solvent. Organic solvents such as ethers, alcohol, chloroform, this type of organic solvent, aldehyde or ketone soluble in organic solvent, lower aldehyde or ketone miscible with water. Clear? Okay, next one we have to discuss here chemical reactions of aldehyde and ketone. Chemical reactions of aldehyde and ketone. First one we have to discuss here nucleophilic addition. Nucleophilic addition. Okay, so this is the mechanism for nucleophilic addition. So here we know in aldehyde and ketone, carbonyl group, this is the functional group, carbonyl group. Here oxygen is highly electronegative and oxygen getting a partial negative charge and carbon get partial positive charge. Okay, so here this is nucleophilic addition and this is the mechanism. Here first step, nucleophile will attack on positively charged carbon atom and form a tetrahedral structure. In second step, after acidic hydrolysis, here this O- will change to alcohol. Okay, and here we know carbon oxygen double bond and it is sp2 hybridized, more S character. After nucleophilic addition, sp2 hybridized carbon atom change to sp3 hybridization. Okay, sp2 hybridized carbon will change to sp3 hybridization, and here after nucleophilic addition it get a tetrahedral structure. Okay, and here first step it is slowest step and rate determining step. Clear? And here next point we have to discuss here reactivity of aldehyde and ketone. Here we have to say aldehydes are more reactive. Aldehydes compared to ketone, aldehydes are more reactive, because in ketone there are two bulky group in ketone, and there will be more or these two bulky group hinder the approach of nucleophile to positively charged carbon atom. Okay, so here nucleophile cannot approach positively charged carbon atom easily, because there are two bulky group. This bulky group make one steric effect, or they make a barrier between positively charged carbon atom and nucleophile. That's why here ketones are less reactive and aldehydes are more reactive. Okay, so these are the things we have to understand about nucleophilic addition. After nucleophilic addition, sp2 hybridized carbon changed to sp3 hybridized carbon, a tetrahedral structure formed, and here aldehydes are more reactive than ketone, because in ketone there are two bulky group. They make more hinder to approach nucleophile to positively charged carbon atom. Clear? Okay, next one we have to discuss here important example for nucleophilic addition. Important example for nucleophilic addition. First one, reaction with hydrogen cyanide. First one, reaction with addition with hydrogen cyanide, HCN. Okay, this chemical reaction takes place in presence of alkali, in presence of base. Okay, also product formed by this chemical reaction is cyanohydrine. Okay, and here we are talking reaction with hydrogen cyanide. Okay, so this chemical reaction takes place in presence of base. So hydrogen cyanide in presence of base, it form water and Cn minus. We know Cn minus, it is nucleophile. It will undergo addition reaction with carbonyl group. Okay, so Cn minus will add on positively charged carbon atom. Okay, here first one intermediate product is formed, intermediate compound formed. Okay, further hydrolysis, acidic hydrolysis, it will change to cyanohydrine. Okay, here O minus change to OH, cyanohydrine formed. Okay, so here reaction with hydrogen cyanide, Cn minus nucleophile, Cn minus will join with positively charged carbon, and O minus will change to OH, and this product is called cyanohydrine, and this chemical reaction takes place in presence of base such as NaOH, KOH, etc. Okay. Another example for nucleophilic addition, reaction with sodium hydrogen sulfite. Sodium hydrogen sulfite mean NaHSO3, sodium hydrogen sulfite. Okay, so here carbonyl group reacted with sodium hydrogen sulfite. This is the final product. Here oxygen, on the oxygen atom, here this is carbon. Okay, here carbon, OSO2Na. OSO2Na, here NaHSO3, okay, here this hydrogen will join with the oxygen OH, and here rest SO3Na, that is here 2 oxygen and 1 oxygen, SO3Na. Okay, and this product is crystalline state. This is crystalline product. Okay, solid crystalline state. And here this product is called bisulfate addition compound. This is bisulfate addition compound. Clear? And here this is the intermediate product formed. Okay, here look here, in intermediate here ONA and OSO2H. Final product, here rearrangement takes place and OSO2Na and here OH. Okay, after rearranging, here final product formed. Clear? So these are two examples for addition reaction, nucleophilic addition reaction. Okay, next one. Next addition reaction we have to discuss here, reaction with alcohol. Okay, aldehyde and ketone react with alcohol in presence of hydrogen chloride. Hydrogen chloride, HCl in gaseous state. Okay, aldehyde reacted with alcohol in presence of HCl, a product formed, a intermediate product formed, that is hemiacetal alkoxy alcohol. So look here we discussed aldehyde reacted with alcohol. Aldehyde, this is aldehyde, it reacts with the alcohol in presence of HCl in gaseous state, and an intermediate product form. This is intermediate product, it is hemiacetal. Hemiacetal, or we can say alkoxy alcohol. Alkoxy, look here, this part alkoxy alcohol. Okay, alkoxy alcohol. Okay, that is intermediate product. This intermediate product again reacted with another alcohol in presence of HCl. This OH part again converted into OR. Okay, so here this is acetal. Okay, this is hemiacetal. Here half of this part there is OR, that is hemiacetal. Now here both side OR, so it is acetal. Okay, so look here, actually this is aldehyde RCHO. RCHO mean this is RCHO. Okay, when it reacted with alcohol ROH, so what happened here, this OR, ROH mean, you know, ROH mean it is OR minus plus H plus. Okay, so this H plus will join with oxygen and change to OH, and this negatively charged part coming here OR. Okay, that is OROH. That is hemiacetal. This hemiacetal again reacted with OROH. So this part again changed to OR. Okay, so this is final product here, acetal. So here remember, aldehyde reacted with alcohol in presence of hydrogen chloride gas, acetal will be formed. Hemiacetal will be formed. Hemiacetal further reacted with alcohol in presence of HCl. Acetal is the final product. Clear? Next one, let us check here ketone. We know this is ketone, this is positively charged part, this is negatively charged part. Okay, so here we choose here glycol. Okay, this is diol. Okay, there is 2 OH functional group. Okay, it reacted with this functional group. We will obtain this type of a compound. Okay, CH2O. And this oxygen and this 2 hydrogen reacted to form water molecule. Look here this hydrogen and one of this hydrogen reacted to form water molecule. Rest of the part, these 2 here double bond, one bond came to this bond, another bond came to this oxygen atom, and we obtain this type of structure. Okay, and here this product is called ethylene glycol ketal. Here we said acetal. Similarly here we will say ketone. Okay, this is acetone. We know this is acetone, acetal. Okay, this is ketone, ketal. Okay, ethylene glycol. This is glycol, ethylene glycol ketal. Okay, why this ethylene glycol? Here 2 carbon atom and its name ethylene glycol. Okay, ethylene glycol with the ketone, that is ethylene glycol ketal. Ethylene glycol ketal. Okay. Next one we have to discuss here reduction. Okay, there are several reduction. First one, reduction to alcohol. Reduction after product will be alcohol. Here these things basically we discussed in +1 textbook. Okay, you can revise it. Here aldehyde after reduction, primary alcohol is the product. Aldehyde after reduction, primary alcohol. Ketone after reduction, secondary alcohol. Okay, Aldehyde after reduction, primary alcohol, ketone after reduction, secondary alcohol. For this type of reduction, we have to use reducing agent lithium aluminum hydride or sodium borohydride, LiAlH4 or NaBH4. This used as reducing agent. Aldehyde after reduction, primary alcohol, ketone after reduction, secondary alcohol. Okay, next one we have to discuss here reduction. Here reduction final product will be hydrocarbon. Here we discuss reduction to alcohol. Next one reduction to hydrocarbon. Reduction to hydrocarbon. Okay, reduction to hydrocarbon, we have to discuss here two type of chemical reaction. First one, reduction in presence of zinc amalgam HCl, zinc amalgam and concentrated HCl. Okay, first one, reduction to hydrocarbon, first chemical reaction. This chemical reaction takes place in presence of zinc amalgam, zinc amalgam. Okay, amalgam means metal with mercury, that is amalgam. Okay, zinc amalgam and concentrated HCl. Aldehyde or ketone will change to hydrocarbon. Okay, so look here, aldehyde, this is carbonyl functional group in aldehyde or ketone. Okay, this reacted with concentrated HCl in presence of zinc amalgam, product will be hydrocarbon and side product water. This chemical reaction is called Clementine Reduction. Okay, named reaction. So I told you previous class you had to make a short note on Clementine Reduction. Sorry, you had to make a record about named reaction. Wolff Krishna reduction, Reimer-Tiemann reaction, Cobb's reaction, similarly Wood's reaction, Wood-Spittig reaction. This type of reaction already we discussed. You have to make a record about this. Okay, you have to add this named reaction. Okay, in such record you have to add this named reaction. Here Clementine reduction. Clementine reduction means aldehyde or ketone after reduction it will change to hydrocarbon. What is the reagent used in Clementine reduction? Zinc amalgam and HCl. This is the reagent used. Clear? Next one here I told you reduction to hydrocarbon. There are two reactions. First one Clementine reduction. Next one Wolff-Krishna reduction. Wolff-Krishna reduction. Wolff-Krishna reduction means aldehyde or ketone reacting with the hydrazine. Okay, here aldehyde or ketone reacting with the hydrazine in presence of sodium or potassium hydroxide. Sodium hydroxide or potassium hydroxide. The sodium hydroxide or potassium hydroxide mixing with ethylene glycol. Okay, so here solvent used glycol, ethylene glycol, here solvent not water. This chemical reaction not taking place in water medium. Okay, here the medium of reaction taking place in ethylene glycol. So hydrazine, sodium and potassium hydrazine, these are mixed in ethylene glycol and treating with aldehyde or ketone. This aldehyde or ketone will change to hydrocarbon. Look here, this CO changes to CH2, hydrocarbon. Okay, and here this is the intermediate product form. Carbon double bond nitrogen NH2. Okay, this is intermediate product. This again treated with the potassium hydroxide, ethylene glycol. Here hydrocarbon formed and nitrogen released. This chemical reaction is called Wolff-Krishna reduction. So here we are talking here chemical reactions of aldehyde or ketone. Here we discussed reduction. Okay, reduction to alcohol, primary or secondary aldehyde or ketone after reduction, primary or secondary alcohol formed, NaBH4 or LiAlH4 used as reducing agent. Next one we discuss reduction to hydrocarbon. Reduction to hydrocarbon, first one Clementine reduction, zinc amalgam and HCl used as reagent in Clementine reduction. Next one we discuss Wolff-Krishna reduction. Wolff-Kirchner reduction, Wolff-Kirchner reaction or Wolff-Kirchner reduction. This chemical reaction is reduction. That's why we will say Wolff-Kirchner reduction. Here in Wolff-Kirchner reduction, hydrazine and sodium or potassium hydroxide in ethylene glycol used as reagent. Okay, reagent for this chemical reaction. Hydrocarbon is the final product. Hydrazine means this is hydrazine, NH2. Okay, here nitrogen, here two hydrogen, again here another nitrogen with the two hydrogen. This compound is called hydrazine. Okay, so here Wolff-Kirchner reduction and Clementine reaction. Okay, next one we have to discuss here oxidation of aldehyde and ketone. Okay, so here aldehyde after oxidation it will change to carboxylic acid. Aldehyde after oxidation, carboxylic acid will be the product. Okay, also here aldehyde it will oxidize very easily. Even mild oxidizing agent, in presence of mild oxidizing agent, aldehyde gives carboxylic acid. Aldehyde will oxidize in presence of Tollens and Fillings reagent. In presence of Tollens reagent and Fillings reagent, aldehyde will oxidize and gives positive result. Okay. Also, Tollens test and Fillings test. This is one identification test for aldehyde and ketone. Only aldehyde gives positive result with the Tollens reagent and Fillings reagent. Ketone do not give positive result with Tollens reagent and Fillings reagent. Okay, so here aldehyde it will oxidize very easily, even in presence of mild oxidizing agent. Aldehyde gives carboxylic acid. But ketone it will oxidize in presence of strong oxidizing agent. Ketone oxidize in presence of strong oxidizing agent. Okay, also it need strong oxidizing agent, also it need higher temperature. Strong oxidizing agent, example acidified potassium dichromate. Okay, sorry, acidified potassium permanganate. Acidified potassium permanganate used as strong oxidizing agent. Okay, so ketone after oxidation, carbon-carbon single bond, carbon-carbon bond breaking takes place. Okay, for example, this is one ketone. After oxidation in presence of strong oxidizing agent, carbon-carbon bond cleavage takes place. Carbon-carbon bond cleavage takes place. After that, a mixture of carboxylic acid will be formed. A mixture of carboxylic acid obtained after oxidation of ketone. Okay, so there will be a random bond breaking. Okay, there is no fixed product. Okay, so bond breaking here, carbon-carbon bond breaking takes place randomly, and a mixture of carboxylic acid will be product. So aldehyde oxidize easily, ketone oxidize in presence of strong oxidizing agent and higher temperature. So here we discuss Tollens test and Fillings test. So here we have to discuss next one, Tollens reaction or Tollens test. Tollens test, it gives positive results with aldehyde. Aldehyde will change to carboxylic acid. So this is one aldehyde. After chemical reaction it will be carboxylic acid. So during Tollens test, what type of chemical reaction takes place? Oxidation takes place. Okay, during Tollens test and Fillings test, oxidation takes place. Tollens reagent mean ammoniacal silver nitrate. Ammoniacal silver nitrate. Okay, that is Tollens reagent. Okay, Tollens reagent mean mixture of ammoniacal silver nitrate and alkali. This chemical reaction takes place in alkaline medium. So this mixture is Tollens reagent. Okay, so here for this chemical reaction we have to use freshly prepared ammoniacal silver nitrate. Freshly prepared ammoniacal silver nitrate. So here mixture of ammoniacal silver nitrate and alkali. Okay, this is Tollens reagent. This Tollens reagent reacted with the aldehyde. Here a silver mirror precipitate will be formed. That is observation. During this chemical reaction, positive result observation is a silver mirror precipitate formed. Okay, so the formation of silver mirror precipitate, it indicate presence of aldehyde. So only aldehyde give this result and ketone do not give this result. Okay, so this is the chemical equation. Aldehyde reacted with ammoniacal silver nitrate in presence of alkali, sodium hydroxide or potassium hydroxide. Here silver mirror precipitate is formed. Silver mirror precipitate formed. Clear? And here aldehyde oxidized to carboxylic acid. Okay. Okay, next one we have to discuss here Felling's test. Next one we have to discuss here Felling's test. Already we discussed Tollens test. Felling's test. For Felling's test we have to use Felling's reagent. Felling's reagent means mixture of Felling solution A and Felling solution B. Okay, for Felling's reagent there are two solutions, Felling solution A and Felling solution B. We have to take equal volume of Felling solution A and Felling solution B. Then we have to warm the mixture with aldehyde. Okay, if there is aldehyde, we will obtain red brown precipitate. So this is the observation for this chemical reaction. A red brown precipitate obtained, it indicate presence of aldehyde. Ketone do not give positive result for Felling's test. Okay, ketone do not give positive result with the Felling's test and Tollens test. Clear? So already we discussed Tollens test. Aldehyde will be oxidized and changed to carboxylic acid. Okay, also here in Felling's test, aldehyde will change to carboxylic ion. Also here oxidation takes place. So here we discuss for Felling's solution. For Felling's test we have to use Felling solution A, Felling solution B. Felling solution A mean aqueous copper sulfate. Aqueous copper sulfate solution, that is Felling solution A. Felling solution B mean alkaline sodium potassium tartarate. Okay, it is alkaline nature. Sodium potassium tartarate. It is one compound. Okay, sodium potassium compound, sodium potassium tartarate. Okay, so it is this compound also called Rochely salt, sodium potassium tartarate or Rochely salt. Okay, so we have to take equal volume of Felling solution A, Felling solution B, and react with aldehyde, and we will obtain a red brown precipitate. So this is the equation for this chemical reaction, aldehyde. Okay, so this is the part of Felling solution. Okay, 2Cu2 plus 5OH minus. Here aldehyde will change to carboxylic ion, and here Cu2O, copper oxide formed. This copper oxide appeared like a red precipitate or red brown precipitate. Okay, so here oxidation takes place. So this is about Felling's test. So for Felling's test there are two solutions, Felling solution A, Felling solution B. Okay, and we have to remember aqueous copper sulfate and here sodium potassium tartarate. Okay, and here oxidation takes place, observation red brown precipitate only aldehyde gives, and here remember aldehyde 2Cu2O, this is the observation, this is the red precipitate, 2Cu2 plus 5OH minus, and here carboxylate ion, and here Cu2O plus 5H2O. Okay, so this is H2O will be side product. So this is the Felling's test. Next one we have to remember here, next chemical reaction, aldol condensation. Next chemical reaction, aldol condensation. Aldol condensation. Actually, aldol mean a compound which contain both aldehyde and alcohol. Okay, so the compound which contain OH, we know OH means the functional group of alcohol. Also the compound which contain carbon double bond oxygen and single bond hydrogen. Okay, aldehyde and alcohol. So such type of compounds are called aldol. Okay, so by this chemical reaction we will obtain aldol or ketone. Aldol means the compound which contain aldehyde and hydroxyl group, aldehyde and alcohol functional group, that is aldol. Ketone means the compound, the product formed which contain ketone and alcohol, that is ketone. That's why this chemical reaction commonly called aldol chemical reaction. Okay, but aldol condensation means this chemical reaction common for aldehyde and ketone, not only aldehyde. Aldol condensation means this chemical reaction common for aldehyde and ketone. Okay, by this chemical reaction aldehyde gives aldol and ketone gives ketone. Aldol means the compound which contain aldehyde and alcohol. Ketone means the compound which contain ketone and alcohol, that is aldol. Here aldol and ketone are the product, but generally the reaction name aldol condensation. Okay. Also you have to understand this chemical reaction. For this chemical reaction, aldehyde or ketone which contain at least one alpha hydrogen. At least one alpha hydrogen. What do you mean by alpha hydrogen? This is aldehyde. We know CH3, C double bond oxygen, hydrogen. Okay, and here this is the functional group, aldehyde functional group. And this is the next carbon. Okay, this is alpha carbon. If there is any other carbon, this is beta carbon, this is gamma carbon. So here aldehyde or ketone which contain alpha hydrogen. Alpha hydrogen means this is alpha carbon and hydrogen present in this carbon, that is alpha hydrogen. Okay, so aldehyde or ketone which contain at least one alpha hydrogen, it gives it react or it gives aldol condensation. Clear? Okay, so here next one, example for aldol and ketone. Okay, so here we discuss aldol condensation mean aldehyde or ketone which contain at least one alpha hydrogen, they gives aldol and ketone. Okay, this aldol and ketone after dehydration gives further final product. So here, see here, two molecules of aldehyde after reaction with sodium hydroxide. Okay, so this two chemical reaction takes place in presence of alkali, and here this alkali act as catalyst. Okay, so in presence of alkali, here aldehyde gives aldol. Aldol mean here this compound which contain aldehyde and alcohol functional group. Okay, after strong heating, water molecule will be removed. This OH and one of the hydrogen will be removed, and here double bond formed. Butenol. Okay, in second carbon there is double bond, that is ENE, and the first carbon there is aldehyde. So butenol, this is the final product. Okay, similarly see here, this is ketone. Okay, two molecules of ketone in presence of barium hydroxide, ketol formed. Ketol mean here ketone functional group, also alcohol functional group. Okay, so here this compound after strong heating, water molecule will be removed. One of this OH, okay, this OH and one of this hydrogen removed, and there will be double bond. Okay, so this is the final product for methyl pent 3En2 on. In second position, this is second carbon there is ketone functional group. Okay, and this is third carbon there is double bond ENE. Okay, and this is fourth carbon there is CH3 side chain. That's why 4-methyl pent 3En2 on. Okay, so these are the example for aldol condensation. Next one, we have to discuss here cross aldol condensation. We already discussed aldol condensation. Okay, next one we have to discuss cross aldol condensation. Okay, aldol condensation means two molecules of same aldehyde after condensation form aldol. After aldol dehydration form alkene. Okay, alkene which contain different functional group. Similarly, two same molecules of ketone. Okay, two acetone undergoes aldol condensation. Two acetone. Okay, two molecules of same ketone. Two molecules of same aldehyde. Okay, that is aldol condensation. Same molecules. Okay, two same aldehyde molecule or two same ketone molecules, that is aldol condensation. But here cross aldol condensation mean here different aldehyde, different molecules of aldehyde or different molecules of ketone, or one aldehyde and one ketone, they undergo condensation reaction and form aldol and ketone. Such type of chemical reactions are called cross aldol condensation. Such type of chemical reactions are called cross aldol condensation. Okay. So here example for cross aldol condensation. See here we have CH3CHO. Okay, ethanol, and here CH3CH2CHO, propanol. These are different aldehyde. It contains 2 carbon atom and it contains 3 carbon atom. So they are different aldehyde. They react in presence of sodium hydroxide. After strong heating, they formed final product. So here we did the chemical reaction in single step. In aldol condensation we did first reactant, then it formed aldol. Aldol after dehydration form a product which contain aldehyde and ketone. We did like that, but here we did the chemical reaction in single step. Okay, here the reagent sodium hydroxide used, also we heated strongly, so we used a single step to show the chemical reaction. Okay, so here CH3CHO and CH3CH2CHO after aldol condensation, here a mixture of product formed. Okay, so one is major product and another one minor product. Okay, so here to name this one we have to number this direction. Okay, so here 2-methyl-butene. Okay, 2-methyl-butene. Okay, this is the name of this compound, and here it will be butenol. Okay, because it is aldehyde, 2-methyl-butenol, and here it is 1, 2, 3, 4, 5 carbon, and here second carbon there is double bond, so pentenol. So a mixture of product formed during this aldol condensation. So cross aldol condensation mean two different aldehyde or different ketones are used, or we can use one aldehyde and one ketone for this chemical reaction. So look here, such type of chemical reaction, here one aldehyde and this is ketone. They undergoes aldol condensation. Okay, here also first step sodium hydroxide or potassium hydroxide alkali use. Second step here we used higher temperature. Okay, so in a single step we showing this chemical reaction, and this is the final product. Okay, this is the final product. Okay, and here 3 carbon, 1, 2, 3 carbon. In first carbon and third carbon there is benzene ring as a side chain, and here first carbon there is carbon-carbon double bond. Okay, so here we can give number from this direction 1, 2, 3, because here first carbon there is carbon oxygen double bond, ketone functional group here, so we have to give number 1 for this carbon. So 1, 3 in first carbon, third carbon there is benzene, 1, 3 diphenyl prop 2 in 1 on. prop-to-ene. Prop-to-ene mean in second carbon there is double bond, ene, ene. Okay, and first carbon there is on mean ketone functional group. So name of this compound 1,3 diphenyl prop-to-ene 1 on. So these are the example for cross aldol condensation. So remember, cross aldol reaction mean here two different aldehyde molecule or two different ketone molecule or one aldehyde and one ketone condensation gives aldol or ketone. Further chemical reaction give aldol product and ketone product. Okay, such type of chemical reaction, cross aldol reaction. Okay, next one we have to discuss here other chemical reaction. So here we discuss oxidation, reduction, nucleophilic addition. This type of chemical reactions are discussed. Next one we have to discuss here other chemical reaction. Other chemical reaction, first one Canizarro reaction. Canizarro reaction means aldehyde which do not contain alpha hydrogen. We know aldehyde, carbon double bond oxygen, single bond hydrogen, and here one carbon it contain hydrogen. This is alpha hydrogen. Okay, aldehyde, this is functional, this is first carbon, this is alpha carbon, hydrogen in this carbon, that is alpha hydrogen. So here Canizarro reaction takes place. Aldehyde do not contain alpha hydrogen. Aldehyde, there is no alpha hydrogen. Such type of aldehyde undergoes Canizarro reaction. Okay, so here in this reaction two molecules of aldehyde involve Canizarro reaction. Two molecules of aldehyde. One molecule undergoes addition reaction and another reaction. One aldehyde undergoes reduction and another aldehyde undergo oxidation. Okay, so one chemical reaction there is both reduction and oxidation takes place. Such type of chemical reactions are disproportionation reaction. So here we are talking here Canizarro reaction. Canizarro reaction mean here aldehyde they do not contain alpha hydrogen. Such type of aldehyde undergoes Canizarro reaction. Two molecules of aldehyde involve Canizarro reaction. One aldehyde reduce and another aldehyde oxidize. So same chemical reaction, one chemical reaction there is both reduction and oxidation takes place. Such type of chemical reactions are called disproportionation reaction. So here I told you two molecules of aldehyde involved in this chemical reaction. One aldehyde molecule after reduction it will be primary alcohol. Another aldehyde after oxidation it will be carboxylic acid. Okay, so same chemical reaction, both oxidation and reduction takes place and the product will be one alcohol and one carboxylic acid will be formed. Such type of chemical reaction Canizarro reaction. So Canizarro reaction there is both reduction and oxidation. Okay, so this is one example. See here same type of two molecules of aldehyde, acetaldehyde. Okay, this is methanol. Methanol after Canizarro reaction. Also, you have to understand this chemical reaction takes place in presence of concentrated alkali. Concentrated sodium hydroxide or concentrated potassium hydroxide. Okay, so here's HCHO. This is aldehyde. Same type of two molecules of aldehyde after Canizarro reaction in presence of concentrated potassium hydroxide, one molecule changed to alcohol CH3OH and another one carboxylic acid HCOOH. Okay, so this is Canizarro reaction. Two same type of aldehyde after reacting with the concentrated potassium hydroxide, one alcohol and one carboxylic acid formed. Okay, so look here, this is another example. Look here, this is aldehyde and this is carbon. This is alpha carbon and you can see here this is carbon. Okay, so here single bond, here 1 2 3 4 bonds are here, so there is no hydrogen, so there is no alpha hydrogen. Okay, so here this is benzene ring and here this is the carbon, this is the alpha carbon. Here 1 2 3 4 bonds are here, so there is no alpha hydrogen. So this is also aldehyde, they do not contain alpha hydrogen. This type of two molecules of aldehyde, this is benzaldehyde, this is benzaldehyde. Two molecules of benzaldehyde in presence of concentrated alkali, concentrated sodium hydroxide. Okay, one is alcohol and one is sodium salt of carboxylic acid, sodium salt of benzoate, sodium salt of benzoate, and this is benzyl alcohol, alcohol and carboxylic acid formed. So here reduction and here oxidation takes place. Okay, so these are example for Canizarro reaction. So Canizarro reaction, disproportionation reaction takes place, and here aldehyde, they do not contain alpha hydrogen, undergo Canizarro reaction, and these are the things. Also this chemical reaction takes place in presence of concentrated alkali, that is Canizarro reaction. Okay, next one we have to discuss here last chemical reactions in aldehyde and ketone part. Last chemical reaction, electrophilic substitution reaction, electrophilic substitution reaction. Okay, so here aromatic aldehyde or ketone, aromatic aldehyde or ketone undergoes electrophilic substitution reaction. Okay, so here this aldehyde or ketone, it contains carbon double bond oxygen, carbonyl group. This carbonyl group, it is meta position, it deactivate meta position. We already discussed haloarenes, benzene ring. On the top of benzene ring there is halogen. This halogens, there is electron pair, they conjugate with the pi electrons of benzene ring, and ortho and para position will be deactivated, ortho and para position getting negative charge. Also similarly phenol. Okay, phenol, in benzene ring there is OH contain oxygen contain electron pair, it will conjugate with the pi electrons of benzene ring, ortho and para position deactivated, ortho and para position getting negative charge. We discussed this type of things before. Similarly here this is benzaldehyde or aromatic aldehyde or ketone, there is carbonyl group. This carbonyl group deactivate meta position, this is ortho position, meta position, para position. So this carbonyl group deactivate meta position, this you have to remember. Halogen deactivate ortho and para, phenol deactivate ortho and para position. Here carbonyl group, aldehyde and ketone contain carbonyl group, they activate meta position. Okay, so here only one reaction we have to discuss here, benzaldehyde treated with a nitrating mixture. Nitrating mixture means mixture of concentrated nitric acid and sulfuric acid at 273 Kelvin, meta nitrobenzene, meta nitrobenzaldehyde will be formed. Okay, so here this is nitrating mixture, nitro NO2 will be substitute, this NO2 will be in meta position because aldehyde and ketone carbonyl group, it deactivate meta position, that's why NO2 coming in meta position. So here it is meta nitrobenzaldehyde, meta nitrobenzaldehyde. Okay, next one we have to discuss here last part of this video. Last part of this video we have to discuss here different uses of aldehyde and ketone. Aldehyde and ketone used as solvent for many substance, many organic or inorganic substance. Aldehyde and ketone used as solvent. Okay, also here formaldehyde or formalin, 40% solution of formalin, it used to preserve biological specimen biological specimen. Okay, to preserve this biological specimen we will use formalin or we can say formaldehyde, aldehyde. Okay, also acetaldehyde is very important starting material for the production of many substances. Acetaldehyde used to make acetic acid, ethyl acetate, vinyl acetate, many different type of polymers, drugs. Okay, for this production we will use acetaldehyde. Okay, acetaldehyde, acetic acid, ethyl acetate, vinyl acetate, different type of polymers and drugs. Also here benzaldehyde used to make different type of perfumes and drugs. Okay, benzaldehyde, perfume and drugs. Okay, so these are the different points we have to discuss in this video. Okay, and in this chapter carboxylic acid, preparation of carboxylic acid, chemical reactions of carboxylic acid rest, and we will discuss these things next video. Okay, so thank you for watching this channel.